Hi, everybody. It's Professor Mitchell, continuing with Chapter 2. Today, we're looking at Section 2.5 on formulas and problem solving. The two objectives in this section are to use formulas to solve problems and solve a formula or equation for one of its variables. And like the last section, this comes under SLOD, solving application problems using linear methods. No nonlinear just yet. All right, so when we talk about a formula, we're talking about an equation that states a known relationship among multiple quantities. Formulas always have more than one variable in them. Some examples of formulas that you'll see in this section are area equals length times width for the area of a rectangle. Interest equals principal times rate times time. That's a formula for simple interest. P equals A plus B plus C, which is the formula for the perimeter of a triangle. In general, the perimeter of any shape is found just by adding all of its sides together. So there's really nothing special about a triangle for this. Distance equals rate times time. I have an example where I will use that formula. And we will encounter some others. Oh, here's one more. The volume of a rectangular solid is the length times the width times the height. So what I would recommend as you do this section, especially when you're doing the homework, is to maybe keep a list of all the formulas that you have to use. Because that list might come in handy later. All right, so here is an example of evaluating a formula. This is pretty easy. We're going to substitute the given value into the formula and solve for the unknown variable. If necessary, we'll round to one decimal place. So the formula is V equals 4/3 pi r cubed, which happens to be the formula for the volume of a sphere. And we're going to evaluate this formula when r equals 3. Now, you will encounter several problems involving the number pi, and they will tell you in the directions how they want you to deal with pi. So in this case, they're telling me to use a calculator approximation for pi. In other problems, they might ask you to use the approximation 3.14 or even the fractional approximation 22/7. So that will be stated in the directions. What I find interesting about this problem in particular is that if you use the wrong kind of approximation for pi, it throws off the answer just enough, where if you were to put it in your online homework, it would actually mark it wrong. So let me switch over to the tablet and show you how I would do this problem. All right, here we go. V equals 4/3 pi r cubed. R equals 3. So I'm going to substitute 3 for r. V equals 4/3 pi. I'll put a blank space for the 3, and then I will fill in the 3. Okay, so that kind of makes it into an order of operations problem. 3 cubed is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Okay. So we've turned it into 4/3 pi times 27. So now, as usual, I will sneak a 1 underneath the 27. And 3 and 27 have a common factor 3. 3 divided by 3 is 1. 27 divided by 3 is 9. So that leaves us with 4 times pi times 9, which is 36 pi. This happens to be the exact answer. but they asked us to use a calculator approximation for pi. So I've got my calculator ready here. Let me bring that up. Okay. So this is a graphing calculator, but what I'm about to show you will work on any scientific calculator. So I'm just going to ask the calculator, what is 36 times pi? Okay. Remember, it said to round to 1 decimal place. So this answer would round to 113.1. Let me just show you real quick. If you weren't paying attention and you use 3.14 for pi, you would get 113.04, which to 1 decimal place would round to 113.0. So like I said, it would throw off the answer just enough for your online homework to mark it wrong. So it is important to read the directions. All right, so I'm going to write this symbol, which you may have seen before, means is approximately 113.1. All right, and that's all there is to it. So we'll go back to the presentation. All right, so now we get into examples of solving a formula for a variable. So solving a formula for a variable means two things. Take letter A, for example. It says to solve that formula for B. So let me actually switch over to the tablet, and I'm going to talk to you for just a minute about exactly what that means. I'll switch over to the tablet so I can write it down. When we say solve for B, what that means is, whoops. Okay, usually I have pretty decent handwriting, but not always on the tablet. Okay, you have to, number one, get B by itself. Okay, but the other part that sometimes people don't think about is that in order for the equation to be solved for B, B cannot appear on the other side of the equation. And that goes for any time you're solving an equation for a specific variable. Whatever the variable is, those two things have to be true. Okay, so this is a very easy example as far as these go. On a scale from 1 to 10, I'd give it about a 2. So we have A equals pi times A times B. This is a geometric formula. It's the formula for the area of what's called an ellipse. And I'll talk to you more about ellipses at the very end of the semester. All right. We talk about those in chapter 13. Okay, so in order to get B by itself, the thing that's standing in my way is pi times A. So all you have to do is just use the multiplication property of equality. Divide both sides of the equation by pi times A. You see why that works? Because it's going to cancel out that pi, and it's also going to cancel out the little a. All right, so the final answer, how does this formula look when it's solved for B? It would look like B equals big A. What in the heck just happened? I swear I did not write that. Big A divided by pi times little a. All right, so that's the kind of answer we're looking for in this type of problem. Okay, so I'm going to move on to the next example. At any time, if you would like to try the problem ahead of me, I totally encourage that. I love that. Just pause the video, try it, and then come back and compare notes. Okay. So in this case, we're solving the formula or the equation A equals P plus PRT for T. All right. This looks like a finance formula, that simple interest is worked in there. Okay, so we want to get t by itself. So what's standing in the way of getting t by itself is two things. Somebody took the letter t, multiplied it by PR, and then they added p. So I need to undo those things in the reverse order. First, I need to get rid of p, the p that's by itself. Okay, so that's how we do that. So that's going to give me a minus p equals PRT. And now it's kind of similar to the last example. In order to get t by itself, I need to divide both sides by PR. Okay, so goodbye P, goodbye R. Okay, so I end up with t equals a minus p over PR. Just in case you're looking at those two p's in the answer, the one on top and the one on the bottom, and you're wondering, can you cross those out? The answer is no. I will have more to say about that when we get to chapter 7. But the reason that you can't cross them out is because the p on top is being subtracted. If it was a times p over p times r, then I would be allowed to cross them out, but not when one of them is being subtracted. Okay, so just thought I'd mention that. And the final example, this one's actually very, very similar to the one we just did. If you'd like to pause the video and try this one. Okay, so if hopefully you've tried this problem. What's standing in the way of h being by itself is first that 4LW. So somebody took h, multiplied it by 2W, and then added 4LW. So the adding 4LW, that's the first thing I have to undo. Remember to do that to both sides. So that's going to give me S minus 4LW equals 2WH. And then we're going to divide both sides by 2W, right? By 2, goodbye W. Final answer, H equals S minus 4LW divided by 2W. Okay, and this is another example where if you're looking at the W's, we would not be allowed to cross those out because we have subtraction on top of the fraction. All right, back to the presentation. I believe we're ready to go over the last type of problem in this section. Yes, we have some word problems. These word problems, I think you'll find are maybe not as difficult as the ones in the last section. I'll leave that up to you. All right, so I won't bother showing you all of these on the presentation because I have them all written out on the tablet. Okay, so the first one says, a family is planning their vacation to Disney World. Okay, not the one we have here in California, but the other one. They will drive from a small town outside New Orleans, Louisiana, to Orlando, Florida, a distance of 700 miles, and they plan to average a rate of 55 miles per hour. So the question is, how long will the trip take? Don't forget about Mitchell's commandments. Mitchell's first commandment, thou shalt clearly define a variable. Since they're asking how long will the trip take, I'm going to call that T for time. So I'm going to say length of trip in hours. I know that the answer is going to be in hours because we're given miles and we're also given miles per hour. And if you want to skip to the bottom and do Mitchell's second commandment, you could say the trip will take blank hours. All right, so now we just have to do all the stuff in the middle. So this is an example. We had this formula on the list. The formula that relates distance, which is given, and rate, which is also given, and time, which is what we're trying to find, is the formula D equals RT. All right, so distance is 700 miles. Rate is 55. T is unknown. So now we'll just solve that formula for T by dividing both sides by 55. And we end up with T equals 700 over 55. Okay, now how should you write that answer? Well, your online homework will tell you specifically how they want it. If you were doing this for me on paper, I wouldn't be super picky. I would probably not leave it the way you see it there, 700 over 55. I have two problems with that. Number one, it's not in simplest form. And number two, improper fractions are kind of weird as the answer to word problems. What I often tell classes is just imagine you go into Raley's or Save Mart and ask for 3/2 of a pound of cheese. They'd look at you kind of funny, wouldn't they? All right. So we don't usually answer word problems with improper fractions. We usually answer them either with mixed numbers or with decimals. If you were doing this for me, I would be happy with either one of those. I think, if I remember correctly, that your online homework wants a mixed number for this one. So let's first simplify this. 55 and 700 have a common factor 5. Okay, so the simplified improper fraction for this is 140 over 11. To convert that into a mixed number, you would do 11 into 140. 11 into 14 goes once. 1 times 11 is 11. 11 into 30 goes twice, with a remainder of 8. So what that means is this answer as a mixed number is 12 and 8/11. Okay. I've always thought that the best kind of answer to give for this would be in hours and minutes. I have never seen a single textbook that asks for it in hours and minutes. Right? But anyway, that's fine. All right, next example. A square animal pen and a pen shaped like an equilateral triangle have equal perimeters. Find the length of the sides of each pen if the sides of the triangular pen are 15 less than twice the side of the square pen. All right, so before I do Mitchell's commandments, I think I'd like to draw a picture of this. So we have a square animal pen, and hopefully, you know, by pen, I mean, you know, an enclosure where you would keep, I don't know, pigs or dogs or chickens, and an equilateral triangle. And those two pens have to have equal perimeter. All right, so I'm kind of itching here to define a variable. So I'm trying to decide how I should do that. It's asking for the length of the sides of each pen. So I can't make X stand for both. So I need to pick one. Well, notice what it says next. It says the sides of the triangular pen are 15 less than twice the side of the square pen. So I think it makes the most sense to make the variable stand for a side of the square pen. So why did I go with the square pen and not the rectangular pen? Well, we did an example like this in the last section. They are describing the length of the side of the triangular pen in terms of a side of the square pen. They're saying the side, a side of the triangular pen is 15 less than twice a side of the square pen. So by calling this thing X, we can say that a side of the triangular pen is 15 less than twice X, which is 2X minus 15. Okay. Equilateral means that all three sides have the same length. Okay, so now I'm ready to write an equation. The perimeter of the square, which is 4x, has to equal the perimeter of the triangle, which is 3 times 2x minus 15. That's our equation. All right, so when we solve that equation, we're going to start by distributing the 3, which is going to give us 4x equals 6x, minus 45. Okay, so then if we subtract 6x from both sides, okay, sorry about that. Got a message came up on my computer. Just wanted to make sure it wasn't going to crash. We got negative 2x equals negative 45. Dividing both sides by negative 2. We get that x equals 45 over 2. Or 22.5. You can just ask the calculator, what is 45 divided by 2? It'll tell you 22.5. So now we just want to make sure that we answer their question. That is the length of a side of the square pen. Side of the square pen. Interestingly, they did not give me the units for this problem. I don't know if this is feet or miles or centimeters or what. So I'll just write units. And a side of the, I'm going to just draw a little triangle there because I'm running out of room, is, what would that be? 22.5 was x. A side of the triangular pen is 2x minus 15. So why don't we just do it here? 2x minus 15. If I put a 22.5 in there, 2 times 22.5 is 45. 45 minus 15 is 30. Okay. So the square is 22.5 units on a side, and the triangle is 30 units on a side. All right, and that brings us to our last example. The lowest temperature ever recorded in Oceania was negative 10 degrees Celsius at the Haleakala Summit in Maui, Hawaii in January 1961. They're asking us to convert this temperature to Fahrenheit. So this is one formula that was not on the list at the beginning. Okay. The formula to convert to convert Celsius to Fahrenheit is C equals 9/5. Wait a minute. Hold on a second. Now I'm second guessing myself. Okay, I almost had it. That's supposed to be the F. F equals 9/5 C plus 32. And I was noticing, I don't exactly know why I never put this formula on the list at the beginning. But anyway, here it is. All right. So we're given the Celsius temperature is -10 degrees. So that's going to go here. F equals 9/5 times -10 plus 32. All right, so just like we've done several times before, let's sneak a 1 underneath this -10. 5 divided by 5 is 1. 10 divided by 5 is 2. 9 times -2 is -18. -18 plus 32 is 14. In my 15 years of living in the Central Valley, I don't believe the temperature has ever gotten that low. I think the lowest I've ever seen it here is in the 20s, maybe. 14 degrees Fahrenheit is pretty cold. And that is the record low temperature in Hawaii. All right, so that's going to take care of section 2.5, and we will see you next time.